Okay, here we have a question about gravitational field strength. This is SL, so let's have a look and then hit play when we're ready to see the explanation. Okay, so we've got planets with different diameters, and we've also got planets with different masses. Okay, so we're looking here at our gravitational field strength on the surface, and we're remembering that gravitational field strength is given by gm over r squared. So what I've done here, I've said ge is the gravitational constant, g, which we're going to forget about later, times the mass of the Earth times the radius of the Earth squared. We're going to acknowledge a couple of things. We're going to say that the mass of this planet P, okay, let's just get this right, the mass of the Earth is 18 times that, and so therefore the mass of the planet is the mass of the Earth divided by 18. We also know that the planet P has radius, which is a third of that of the Earth. I've kind of deliberately put this in so that we can have the values in terms of the mass of the planet and the radius of the planet. So we know that we've got a planet which has got a third of the radius, and then an 18th of the mass. We're then going to calculate our GP. GP is just the gravitational constant, times the mass of the planet divided by r of the planet squared, and this is where we're going to put in our numbers. It's a bit messy here, so let's just have a look. We've got g times me divided by 18, that's where that 18 comes from, and then we've got re squared divided by, and then we've got divided by r3 squared. R3 squared has come from the bottom up to the top here. 3 squared is 9, and therefore we're left with a 9 over 18. 9 over 18 is a factor of 2. And you notice here we've got gme over r squared. Well, that was g on the surface of the Earth. Sorry, there should be a subscript e here. All right, well, what that means is that they are out by a factor of 2. Okay, now notice that we use these quite nice numbers, right? 18 and the 3. Initially, you might think, okay, we're going to combine them somehow to maybe make a sixth, but because we squared that third, we're actually getting a factor of 1 over 2. Again, IB loves these kind of questions where you're using ratios and they're coming out as something nice and clean. In this case, it's just half the radius. You can see that from the fact, essentially, that what we've got is different densities of the planet. They've got a higher mass, but different diameter, and therefore that's what's accounting for our change in the gravitational field strength.